just over a year ago, I attended QCon London and I saw this amazing talk by Stuart Davidson at Skyscanner. He spoke about how Skyscanner were doing true continuous deployment, no test environments, no lower environments being used at all. This talk led me to the spot I am today, both giving this talk, but also professionally. I'm Nicky, a principal engineer at Skyscanner. I applied for the job at Skyscanner approximately 3 weeks after I took this dreadful picture of Stuart. Skyscanner is a leading travel site with a truly global market, and I needed to know how they were able to achieve this. So why do we not replicate down to our production to lower environments? Well, historically, we had lower environments that were like production for testing releases, especially where we could not confidently reason about the effects of the changes that we were releasing. Possibly this was due to lack of tooling, lack of test automation, and more recently with more modern monoliths, it's just purely because of the stacking up of PRs against the code base. However, maintaining a production-like environment that behaves just like production is not a simple task. Lower environments need data, not just services and infrastructure, and depending on your system, it can be relatively straightforward to access real-time data in lower environments. However, consistently replicating user behavior is difficult. Those peaks and troughs in traffic that mutate due to time of day or unforeseen circumstances. Load tests cannot anticipate the way that the load will happen. Not to mention that real data carries real responsibility. At Skyscanner, we have a saying called traveller first, and this means being super responsible with all things user related, including their data. Taking user data and publishing it into other stacks means it's harder to reason about where that data is. How can we produce reports on how we are using that traveller's data easily? These are just the problems with intentional use. But what about mistakes, accidental printout of passwords in fields somewhere or logs? How can we effectively scrub that and scrub that quickly when it's distributed over many environments? Then it comes to infrastructure. Even with every nook and cranny of your estate covered as infrastructure as code, you cannot replicate exactly what you have in production in lower environments. Firstly, the cloud providers have given us layers of abstraction over the actual hardware that's running our code. Secondly, we have different permissions and other things that allow engineers more flexibility in lower environments. Thirdly, we have identifiers, ARNs, account references, which invariably mean that we end up separating out the code path for staging, production, and those lower environments. So your process around producing this like-for-like environment needs to be incredibly well defined. How do emergency hot fixes that we do in production end up in the lower environments? But these are difficulties everywhere. What does this actually mean for Skyscanner and why we went towards a production-first approach? Well, this diagram I have used for over a year now, and it doesn't need to be up to date. It just shows that we're creating these exceptionally complex distributed systems. These are just our stateless Java services, not our Python or any other stateless microservice, let alone our stateful. And we have them spread over Kubernetes and ECS at the moment. And we're currently rolling out to 10 regions. Just trying to work out how we replicate that down into lower environments is a massive headache. Our AWS bill is eye-watering at the best of times. I daren't think of the figures if we started replicating these environments. So I personally work on the data platform that delivers all of our application logging, our business events, through to our data lake and our Elasticsearch. We recently bumped into a problem that we've found that there's a hard limit of 4,000 containers allowed in an ECS cluster. And we were dynamically creating these containers when we got a new log event type. Imagine just purely replicating this. The cost of data transfer alone would be enormous. And would we have hit this issue in lower environments? Potentially, but it would mean all of the dynamic creation of the containers needed to be there, all the triggers that led to the event of those containers being created. So new events that are new data events that are being produced in production need to be produced in the lower environments by often disparate teams. Then there's the operational costs. Keeping production alive takes enough of our time already, let alone trying to keep a lower environment that potentially is going to block progression to production alive. We've got then also operational tooling that we need to produce, getting real data, reduction of PII, sampling, and those reconstruction of ebbs and flows. And not to mention, we were going to have spiky loads in production, and we want to try to do our load tests on top of those spiky loads. We had a great spiky load once that a Japanese morning show decided to display our app, and all of a sudden there was a rush to the App Store to download our app and open it, and it saw our infrastructure creaking, and we learned to do our load tests over the top of that. Now, how do we manage to do this? Well, at Skyscanner, we love a cookie cutter. We love cookie cutters so much. Microservices are cookie cut through to our monitoring, our big data ETL jobs. And this is one of the ways that we can provide the engineers with a golden path. Make it easy for people to align to approaches, and then allow them collaboration to evolve those approaches. This gives us a lot of consistency. We even have dummy integration tests to make sure that people are thinking beyond those unit tests. We also have consistency in deployments, GitHub repos, AWS resource tagging, security scanning, and so much more. And it means we can get a microservice, a new microservice of guaranteed quality into production in a matter of minutes. It's worth noting here that although we have owners for all of this code, we do have an idea of internal source code. So everybody can submit PRs to improve the code. And this is especially important for developer experience tooling like this. We also have our own in-house continuous deployment tool called Slingshot, and we can configure it to pull releases based on metrics. The above example is a bit extreme, so we will pull it after having more than 1% of errors, which sounds like a lot. But I've seen this component take 2 million messages per second, so there is a big tolerance there. We also, whilst we're migrating over to ECS, we realized from ECS to Kubernetes, we realized that we didn't want to have a lower environment for our Kubernetes to be able to test it all as is. We wanted to be able to shadow traffic from ECS over to Kubernetes so that we could actually check how things are running in the real world and they behaved the same. One of the most crucial things about our approach is diligence to integration testing. We're not wanting end-to-end tests, these big automated end-to-end tests, because we don't have ownership over the entire thing. So in a well-designed distributed system, you know your boundaries, but you want to just test those contracts as well. We know that there's tools out there which we use, things like Local Stack, which you can spin up AWS resources, and there's also Docker Compose. However, we saw a little bit of a gap in that Docker Compose you'd run for your local testing, whilst your CI was plugged in a different manner and didn't often use Docker Compose. So there's this open source that is heavily contributed to by Skyscanner called test containers. And it meant we could actually spin up containers directly from our code. And this is only for our Java apps at the moment, but it means that the local tests are the same as the CI test runs. There is another benefit to this, is that those containers only lived as long as the tests were run. So any dodgy data from even just the previous test was not considered. So you won't get a shock once you get into production. So we also have a tool called deployable that allows us to automatically raise PRs for library bumps and common libraries. The PR in the background is a PR for an SDK that was used across the organization for all our logging of analytical events, application logs and metrics. So we could iterate on that and push it to the entire organization. We're rolling out a new data ingestion platform. And rather than do it in a lower environment, we're doing it directly in prod, but we're just double dispatching our data. And then we're allowing our visualization tools to abstract over both data sources. A word of warning here, decom is crucial because otherwise you'll end up supporting both the old and the new. There's certain best practices such as instrumentation of codes that can actually make it a ton easier to track issues if you're doing it in prod rather than trying to replicate the issues in lower environments. We also prefer monitoring over end-to-end tests, real data through real live systems reacting to real problems. Above is a monitor that we have for the completeness of our data arrival through our platform, for example. Back to our cookie cutter interface. We have a cookie cutter for our microservices that give us a baseline of standard logging metrics, automatically all set up to send through to our platform. But we also have our alerting system. So it's an open source alerting system called Bosun, which we were heavy users and then recently took ownership of. Here, the squads, through a few clicks, can have their services automatically monitored and hooked up for out-of-hours tooling such as VixRox or PagerDuty. We are also looking at ways that our architecture can support production first. How can we update the software that's running the software? Kubernetes is the best example. Imagine running a Kubernetes cluster, an enormous one with thousands of services from across the business. And then there's an update to Kubernetes that we need to install. We can't test it in lower environments, so we roll it straight to prod. You know where it goes. This happened to us. We took down our entire Kubernetes cluster and we had to resort to rebuilding the entire cluster. Lucky for us, it was a lesson learned early on in our migration, and the impact was not as extensive because we've been actually testing in production and not waiting for a big bang release of our clusters. It allowed us to pivot quickly, and we pivoted towards this idea of cells-based architecture. So in each AZ, we had clusters, each separate clusters running, and the services distributed over those clusters. It meant entire clusters could go down and not affect the availability of the services as they're balanced over many clusters. And it means that a rollout of a bad update means that even if we lost a cluster, we could easily rebuild it and no loss of service. I kind of lied about only having production because we do have this thing called sandbox. However, this is definitely not a fully replicated environment. It's complete cowboy land, more akin to a scratch environment. In fact, we nuke the account every month. We use sandbox sometimes for demos of ideas, but often that's done in production. Validation of approaches, but yet again, that's often in production. POCs, but more often it's a safety blanket. Did things behave the way that I expected? And with all the best practices in the world, it can be daunting to release straight to production. So Sandbox is there to allay fears. However, we really understand that this is not a like-for-like production account. There are circumstances that going to production first is not right. I work in the travel industry. We have a good degree of tolerance to error. There are others that don't. Also, I used this image earlier, which I shouldn't have. Monoliths and application development is definitely a monolithic pattern. You can't push hundreds of app updates to users a day, and you can't easily fail forward, especially if the app is out in the wild. We need to have really good integration tests, but it doesn't mean that we have to replicate our entire infrastructure. We can just again do it at the boundaries. We even have a preview area for our data, so even when it's in this lower environment for the monolith, they can push to a preview area and join up with production data and check their data. Sometimes third parties you need this, but not always. It depends on the third party. Payment accounts can be set up in production that can be redacted. It's definitely dependent on the integration. But it all really comes back to tooling. Even if you were to use a fully replicated lower environment, you'd need to invest in tooling to produce a like-for-like environment. However, investing in tooling to work towards a production first environment means you're actually investing in many things that will have a positive effect on your product's quality, speed to market, operational costs, and cloud bills. It doesn't need to be an all or nothing. You can slowly migrate towards a production first, incrementally reducing the overhead of lower environments. So that's why we do it at Skyscanner, and I hope it's given you some ideas to run with. Thank you.